Okay, timer on. Right, hello. I want to go back to page 53 before I move on to section 4.4. There's a couple of fantastic questions that are working towards grade C, and for that reason I really want to do it. Pen? Yes, good. Right, it says here the original price of a football is £6 and 95p. Alright, that's the original price of it. And it is reduced by 40%, so that's my symbol for reduced by 40%. And Jake says the sale price is £2.78. This is what Jake says. Alright, and the question asks, is he correct? So I'll put it correct. Is he correct? Double question mark, big question. Explain your answer. Well, I want to reduce it by 40%. So using multipliers, jumping straight in, we have 60% of the original value still left. Therefore, 0.6 times 6.95. Grab my machine. .6 multiplied by £6.95 is, it's going to cost me, after my reduction of 40%, it's going to cost me £4.17. Now Jake says that's a sale price of £2.78. Well, actually the sale price is £2.17. Let's investigate what Jake thought about. I suspect he sort of did this. 40% of £6.95. Okay, I'm about to test it out in front of you, so here we go. 0.4 multiplied by 6.95 equals £2.78. So what was Jake's thinking? He actually worked out 40% of the £6.95 but failed to take it away. Now had he used multipliers, he would have got this in one step. So I have to explain what he did. He just worked out 40% of £6.95. He didn't take away the £2.78 away from the £6.95. So Jake's was the actual reduction, but the reduced price, the final reduced price, was in fact £4.17. All right. So let's move on to the next question. Question 12 on page 53. Wish I'd stop moving. So this is question 12 on page 53. Now look at it carefully. It says a zoo puts its prices up by 5%. So that's me going up 5%. In the first week after the increase, it gives a discount of 5%. This is quite serious actually. Sunita says the cost will be back to the old price. Do you agree? Well, I don't know yet, do I? Now, if I'm going to increase something by 5%, I need to multiply by 1.05. Alright? If I'm then going to decrease it by 5%, I now come and multiply by 0.95. Now, if, according to Sunita, it goes back to the old price, when I multiply 1.05 with 1.95, I should get exactly 1. That is to say, 100% of the original price. So let's just try that. 1.05 multiplied by 0.95 is, look at this, I get 0.9975. In other words, thinking out loud, I actually have 99.75% of the original price. So therefore, it doesn't go back to the old price. It's gone slightly below by 0.25%. Now that could be quite hard to see. Let's do a real calculation, inventing a price for a ticket to get into the zoo. So let's go yellow. I love the way it stands out, this yellow. Right, an example. Let's say it costs me, I don't know, £20 to get into the zoo. Let's increase that by 5%. So multiply by 1.05. Grabbing my machine, I've got 20. Multiplied by 1.05. Bam. That's going to cost me £21 with the increase. Now over here, I'm going to take my £21 and drop it by 5%. In other words, multiply by 0.95. See what happens. Now, if all is well, this should drop back down to £20 according to Sunita. Let's take a look. So 21 multiplied by 0.95 takes me to £19.95. Now, dead close, but actually mathematically and in her thinking she's wrong, because that is not the same as the original £20 that we did, alright? They're different, therefore it's not the same. Now, in an exam you can either give a live example like this, supposing a ticket costs £20, etc., etc., or you can go for the sort of the theoretical example where you go straight into multipliers and show that the final result here, for example, is not the same as 1. In other words, it's not equivalent to 1, therefore it's different. Is that alright? Right, I'm going to skip over a page because I want to move on to 4.4. Now, it's a bit messy because I've gone from one section to another, but it's all percentages. But it's really easy. So it says here, writing one quantity as a percentage of another. So jumping straight into question 1A of 4.4, page 55, sticking with the yellow because I like it. It says, write £32 as a percentage of £200. So these are my two figures. Very easy. I'll just do this. 32 out of 200, well that's just a fraction. I merely multiply by 100 to get it as a percent. Don't need a machine for that. Count all down zeros. 32 divided by 2 is 16%. One more? Okay, let's do that. I might need a calculator for this one, but I'm going to go for it anyway. This is D of question 1. I'm going to write £325 as a fraction of £750. Alright, so here we go. This becomes 325 divided by 750 multiplied by 100. No matter how ugly and difficult the fraction may look, still multiplied by 100, and I'm definitely going to grab my calculator for this one as I'll get a headache. So 325 divided by 750 equals, yeah, I definitely get times 100. I'm actually going to get 43, oops, where's that pen gone? 43.3, and it recurs percent. Alright, so it's 43 and a third percent exactly. I may as well write that. 43 and a third of a percent, and that's perfect. Okay, so that's writing one quantity as a fraction of another. I will highlight a different one though. Go to red. There is a reason for this. It says write down 65p as a percentage of £5.20. Now, avoid the error. We cannot have pence and pounds all mixed up in a single fraction because we're dealing with different units. So this will actually become 65 pence divided by 520 pence. See, they're now comparable. Then in the normal way we just multiply by 100 to get it into a percentage. Let's do that quickly now. 65 divided by 520 multiplied by 100 gives us 12.5%, 12.5%. Writing it just here, 12.5%, no problemo. What else we got here? Question 3. In a survey, 28 out of 40 people say they prefer butter to margarine. Very simple. It's 28 over 40 multiplied by 100, and you get your answer. And I'm not too fussed about that, it's all the same now. Getting quite boring. I will do question 6, I've got time for that. Question 6 is a little more involved because what's happened there? That's supposed to be a 6. Let me just rub it out. Don't like that. Off you go. Do it better next time. Let's go for green here. Question 6. There's a little tally chart. I'm not going to draw it for you, but essentially we got colours of eyes. No, hair colour. Okay, never mind. We got blondes. We've got browns. We've got black hair. And we've got red hair, whatever that is. We're given the tally. I'm just going to tell you what the actual frequencies are. Well, 10 blondes, we've got 13 browns, we've got 5 black, and we've got 2 red. Now, before any further, just quickly do a total. We've got there 23 together. 23 plus 7 gives us 30 kids. That's a nice easy number. And the question says, Ian looks at the tally chart. So let's write his name down here. Ian. He's having a little look at the tally chart. That's Ian having a little look at the tally chart. And he says 10% of the class has blonde hair. Is he correct? Well, let's just try it, shall we? blonde hair. Well, that's 10 blondes, so it'd be 10 divided by the total 30. Alright, so 10 out of 30 multiplied by 100, and I'm sure you can see that's a third. A third of 100 is exactly 333. Oh dear, it's awful. Change that back to green. That will be 33.3 recurring percent. In other words, 33 and a third of a percent. Ian says 10% of the class is blonde hair. No, we've just proved that it's not 10%, it's 33 and a third percent. But you have to write in the exam to communicate your final findings. Ian is not correct because 33 and a third percent have blonde hair. Alright, anything else? I may or may not do some of these later on, but anyway, I think you got the idea. This is grade C rated. Once you start working with tables, just want to say that watch out if you've got mixed units, you've got to unmix them. Put a little star by that. This kind of thing I'm looking at here. If it's all mixed up, unmix it. Pennies with pennies, not pennies with pounds. And I don't think I'll do any more of 4.4 because it's getting very repetitive. It's all the same, and I don't need to do that. Okay, so I'm going to stop this. As far as I'm concerned, it's the end of 4.4, and I'm really happy with it.